Welcome to the webinar. Today's topic is SSL or TLS support in Varnish Plus. With me today is Dag Håvi Finstad.
Hello.
Martin Blix Grudland.
Hello.
That's the nice, friendly guy on the motorcycle. And myself, Per Bur. So, the topic for today is secure socket layer, or known as SSL. Actually, it's not, because it's changed its name, I believe, back in 99 or something, because of some trademark and patent issues that the Netscape actually filed on SSL, and it was renamed to Transport Layer Security, or TLS. So, but still, the name SSL is widely used, so we'll be referring to it as SSL/TLS. So, what is TLS? TLS provides a general purpose secure transport channel between two computers. So typically between you and the computer that runs your internet banking. In the sort of OSI stack, it runs on top of TCP and below HTTP. And we call the resulting sort of application protocol HTTPS or HTTP over TLS. So, interesting question is why there is no TLS support in Varnish Cache. And the biggest reason is that there are no good TLS implementations, or at least no good TLS implementations that are license compatible with Varnish Cache. So for the sort of de facto standard library to use for implementing TLS is called OpenSSL, and OpenSSL has quite a few code quality issues associated with it, and it is Paul and Kamp's view that we should not bring that library into Varnish Cache until the quality of that library is a lot higher than what it is. So, and the other TLS implementations that are out there are either licensing compatible or not really worth considering due to quality or just very limited implementations. Writing a new one would take, I guess, a 3-man team at least a year, and that is given that you actually are able to find people that are qualified. In order to do TLS, you have to have a lot of math, and finding someone who's both a decent software developer and knows enough math to actually do this is not easy. So when I talk about TLS with Varnish Plus, we talk about TLS actually in multiple places. A lot of it would be the most important bit would be on the client side. So the communications that are between the client and Varnish, securing those with TLS. So as sort of everything between the client and Varnish flows through that communication line, encrypting that is of course very important. So that's sort of most people are interested in encrypting that part. But there is also one more place where Varnish talks HTTP where you might want to consider encrypting it, and that's sort of towards the backend. Now, there are basically 2 times where Varnish will talk to your backend. Is either because it has a cache miss and it needs to fetch something that's currently not in its cache, or because if it's some sort of a dynamic resource that's uncacheable, and that always Varnish will just sort of pass it through, like a post request, for instance, and it will pass it through to the backend. And And of course, the last bit there is the tricky one, because that part might actually contain quite a bit of private data. So those would be yeah, names, phone numbers, credit card numbers, whatnot. And of course, you can't send that information over any sort of clear text connection over the internet. Of course, if your application servers are in the same data center or the same rack as your Varnish server, the risk, of course, is a lot smaller than would be, because then you're talking about sending stuff in clear text just over a local cable and a switch in your data center, and you can sort of reasonably assume that that connection is secure. However, sort of times are changing slightly, and it's not really that uncommon for an organization to require those connections to be encrypted as well. So some people might want to encrypt that, even though it's on the same in just the same physical network. So the plan that we had that's currently done is the beta release in Varnish Cache Plus was in May 2015. We had a few people beta testing this, and it was quite successful. However, the production release on the 20th of June 2015. So today, that is 10 days ago. Yeah, so it's currently out there and available for Varnish Plus subscribers.
All right.
So I just introduce Dag. So Dag has been our developer that's been working on the client side TLS bits.
Yes, like Per said, I've been working on the client side of our new TLS offering. So what we did is we took this abandoned project known as Stud, and we've forked that, and we've called it Hitch. And we've there has been a lot of development happening around the GitHub in particular on this project from various users, and we've been cherry picking the best patches here and there and put it into this project along with implementing our own features. So Stud was originally done by these guys called Bump Technologies, and later it's been worked on by WhatsApp, I know. It's event driven using libev. So typically you'd run with it forks off a number of processes where you pin each process to its separate core, and it uses non-blocking sockets powered by libev to make it really quite powerful and fast.
Cool. Do you know why the Stud codebase was abandoned?
They were acquired by Google, I think.
Yes.
Yes.
Yeah.
They decided they didn't really want to continue with that project, I guess.
Yeah. No, Google actually killed the Bump product and went for the engineers. And sort of ironically, more or less the same thing happened to WhatsApp, or what WhatsApp was using Stud, and then Facebook acquired them, and Facebook already has a TLS proxy in place, and of course preferred to use that, and they ditched it. So third time's a charm, hopefully.
Let's see. All right. So we've done quite a bit of work on the proxy protocol support for this, for both in Hitch and also in Varnish, actually. So the proxy protocol is sort of a simple protocol that lets you transmit the original connection endpoints involved in the TLS connection. So typically in a situation like this, where you have a separate piece of software terminating the connection in front of your Varnish, you'd lose the original IP number of the client. So this thing here will then write a short preamble header containing the original endpoints for the client and the server involved, and it will then convey this information to Varnish. make it available via the client.ip and server.ip VCL fields in Varnish. So there are two versions of this protocol, but there's the textual version, which is the V1 of the protocol, and there's the second version, which is the binary version. Now we've fixed up and implemented proper support for both of these in Hitch. And also we support both proxy V1 and V2 in Varnish now. And moving on, we've implemented support for multiple listening sockets, and you can set a default certificate for each listen socket. In the event that you don't use SNI, then you can make it use a default certificate. Of course, we also support SNI with and without wildcard.
Could you just quickly tell me what SNI is?
Oh yeah, it's server name indicator. So it's a TLS extension. So typically if you have a virtual server setup with multiple server names on the same IP number, it's a TLS extension that lets the client tell the server which server name it was originally contacting. Okay. So it can then use whichever certificate is proper for this handshake.
Yeah, so it removes the need to have a single IP address for every TLS certificate.
Exactly, yes. So you can have multiple server names on the same IP number.
Yeah.
It makes that work.
Of course, the normal way of HTTP communicating this is via the host header.
Yeah.
That would be too late in the context of TLS.
Yeah, good point. I guess it's sort of the counterpart to the host header and HTTP. Yeah. All right. We've sort of changed a few defaults. So we no longer enable SSL 3.0 by default like it was in stud. We've also removed this recommendation that you should have SSL 3.0 enabled for HTTP traffic. It's kind of, it's not best practice anymore at all. Yeah, and we've done quite a bit to work on the build setup. It now uses AutoTools, which is actually quite useful, contrary to
yes.
There are numerous bug fixes. We've also done this quite rudimentary test suite with some simple integration tests for testing various functionality, which is quite useful when you're working on this. And of course, there's, as I said, it's the integration with Varnish D through the proxy protocol, so we have full proxy support in both Varnish and also in Hitch, of course. Yeah, so this is sort of the general overview of what this is going to look like with Hitch and Varnish. We have the client talking over TLS to Hitch, which is the TLS proxy, talking to Varnish, and then we also have TLS going to the backend. Right. So we've done some simple performance testing of this thing to see where we're at when we've been working on it. So a little bit about the test setup. This was on fairly modern hardware, at least as of 1 year ago, with the client talking to the server on over a 10 gigabit connection. We used this tool Work for as the client, as that is able to create quite a bit of traffic.
Yeah, so Hitch in front of local Varnish through proxy. So Work was running on one.
Yeah, on the other machine.
On one machine, and then the other machine was running Hitch and Varnish.
Yeah. So we wanted this to match the sort of configuration that we see people out there might end up running. Yeah. Yeah. So we also added a few other products in our tests to see how we are doing compared to those guys. So here we see handshake performance. So in this test, it was retrieving a 0-byte object and using connection close. So you have to renegotiate the connection on every single connection. We did permit session reuse, or session resumption. So that has quite a bit of an impact as well.
Okay. So, but every time here the TCP connection would be established.
Yes.
But the secret key would not have to be negotiated.
Yes, if well, to the point where how well these various implementations handle that.
Okay.
Like you could get a cache miss or whatever in the session cache, or
yeah. But do you know if like was work actually sort of was it us only using one secret key here?
it was using a number of connections.
A number of connections,
Yeah.
and each one would
Each one would have been
negotiated a different.
negotiating a session and resume session. Yeah.
Okay.
Yeah. So we see Hitch is a little under 30,000 handshakes per second on this in this setup.
Yeah.
Not quite up there with AJ proxy, but yeah.
Pretty close.
Yeah. So we did a test for throughput. So the numbers here are in megabytes per second, and yeah, we can see Hitch is close to 300 megabytes per second. So it's holding up pretty well with other products out there. And for 4K object sizes, we can see Hitch is also doing very well.
Yeah, actually doing. Yeah, it's the best proxy out
Okay.
there probably for 4K objects.
Like you're only serving 4K objects. We have this.
No, but I mean the average object on the internet is what, like it's quite big.
Yeah.
I think it's way above 4K.
Yeah, I mean,
Isn't it like 75 or 80K? I think no, the average object.
Yeah, arithmetic mean, is it meaningful to?
This graph is lacking a legend.
Yeah, that's in that's in gigabytes per second.
Gigabytes.
Yeah,
per
that is it was a little bit rushed.
Yeah.
So we can see we're very close to saturating the 10 gigabit connection here.
Okay.
Yeah.
Cool.
Mm-hmm.
Got 4K objects. Yeah.
Yeah. All right.
Yeah. So I mean, to sort of sum up, Hitch performance is very good. As you can sort of tell, there's a latency hit on the sort of first connection when you need to sort of renegotiate the TLS secret key. But that's sort of that's the point of TLS really. I mean, and for most installations, the TLS overhead can be neglected. So I guess, I mean, if you have like less than 1,000 connections per second, I would not bother to do anything specific if you are enabling TLS on your website. You can just basically just ignore it. It also means that no new hardware will be required for most setups. I mean, if you have some sort of insane performance requirements, of course, this might be the thing that sort of the straw that breaks the camel's back. But most likely it's not. So we're now going to talk a bit about the other TLS implementation. It is in Varnish Plus, which is the backend side. So that's the communication between Varnish and the backend. And with me here is Martin Blix-Grydland, which is the developer who made this.
Yes, hello everyone. My name is Martin, and on the backend side of things, to complete this picture, we chose to build the support for SSL directly into Varnish D. So there are a couple of reasons that we chose this path rather than have it external that we know some people have been using. One of those is that the implementation of things inside of Varnish D is cleaner cut when it comes to the backend side rather than the client side. There are so many optimizations and such in Varnish D on the client side of things that integrating a new transport protocol isn't for the faint-hearted on that side. But on the backend side of things, it is possible. So we did that, and we also wanted things to become easy on the backend side of things. One implementation detail that makes the backend connections in Varnish very fast is that we are able to reuse connections all the time. And in order to know that we can reuse a connection, we need complete control over the status of that connection. If we chose to put this into a separate product, we lose part of that picture, and we might not get as good reuse of connections as we otherwise could. And especially in the TLS world, that becomes very important, because renegotiating these connections is very expensive in terms of computing power and
Yes.
latency that adds.
It's also very sort of expensive to say it.
Yes.
Yes.
That is true. Some of these words are quite tongue twisters.
Yes.
So when it comes to using this, it's not very much magic to it at all. All you need to do is add a single line to your backend definition that says .ssl equals to 1, and things magically start happening inside of Varnish.
Yes. Yeah, you must also remember to have the other attributes, of course, there as well.
Yes, that is necessary. So you add your host header, and the port will of course default to 443 if you're using this, or if you have some custom, you can say that. And,
but when you said it, so the host, yeah, because the host header would be important for the SNI negotiations.
A host header will be important there, yes. So Varnish will present the actual value of your host attribute by default when it negotiates these connections during the handshake. But often...
taken from the client request?
No, not taken from the client request.
But from the backend definition?
From the backend definition, yes. Varnish will never send the host header as presented by the client, also when not using HTTPS, because we can't really trust the contents of this host header. And given that the backend connections are reused, we do not want the possibility of different host headers being presented to the same backend for different requests. There might be some less intelligent HTTP routers or something in between Varnish and the backend that muddies this picture. So when Varnish does its backend requests, it will always use the host attribute as a host header for these requests, and then also now with SSL use that for SNI when negotiating the SSL to the backend. But many people do not want to use the host name or the DNS name as part of their definitions. This because if something changes in DNS, then suddenly you can't compile your VCL with Varnish complaining that this name now resolves to multiple IP addresses. So they will instead insert the IP address in there. And that is why the backend definitions also have this other attribute called host header. And that host header will, if present, be used instead of the host attribute as both the SNI name and the host header for backend requests.
Okay.
So that host HDR?
No, it is host underscore header.
Oh, okay.
Yes.
Okay.
Host HDR is the internal attribute name inside of the source code. Yeah. And going forward, we can use this opportunity to talk about the cool new features that will be part of Varnish 4.1. Is that in 4.1, one will be able to implement backends as vmods. That means that it is possible to create a vmod that, given a set of headers, can do whatever magic it needs to do in order to present Varnish back a set of response headers and a body of that object. And this, of course, allows all of this work to become a V-mod into the future. So we have been doing some performance tests on this part as well. For this setup, we were using an Nginx backend enabled with TLS. We were using a 2048-bit RSA certificate, and this ended up with negotiating using ECDHE. Done on 2 servers connected by a 10 gigabit LAN. Again, we were using WRK to create the client traffic towards the Varnish that was non-encrypted for these tests.
Yeah, so work was running on the same server as Varnish.
Yes.
And then the Nginx server was across the LAN connection.
Exactly.
Okay.
And for these tests, we have been focusing on latency rather than throughput. When it comes to backend requests, it's the latency question that we want to answer, and that is what we have been focusing on as well. So the purpose was not to push the servers to their maximum, but rather get some good measurements on how much latency using encryption actually adds.
Cool.
So first off here, for this test, we have not been using reusing existing connections. So here we were always doing the full TLS handshake for each backend request being made. And of course, this is where the TLS encryption really suffers in that there is a lot of expensive math happening behind the scenes in order to create the session keys and everything here. And we can see that the difference between HTTP and HTTPS is significant. It is the latency adds 15 times when enabling the encryption. But as we talked about earlier, Varnish will reuse connections whenever it can, and that will help with this picture, so it doesn't look so bad normally. So going over to what it looks like when we are reusing the existing connections, and here the picture becomes quite a lot better. You can see here that there's still some penalty happening here, but the numbers are order of magnitude less for both of them.
Yeah.
And the encrypted connections still take around 3.5 times as long to complete. The main reason for this not being as performant as the HTTP is that the number of system calls increases when we are using TLS. So we have lots more context switches happening for each communication. This was done using a 1K object. No, it's a 4K object, sorry. And when object sizes increase, there will be fewer system calls, so then the picture will be slightly better. But still, there is some penalty to it. But latency here is not bad at all. Consider that this is across the LAN.
It's still below 1 millisecond.
Yes.
Which is quite fast.
That is true.
Yeah.
For these tests, we wanted to mimic what the picture looks like when your backend server is not in the same data center as your Varnish server. To do this, we added this artificial 100 millisecond additional latency to all packets. And looking at the new connections every time, the top graph there, the picture now is around twice as much latency compared to regular HTTP traffic. But the bottom graph there is quite interesting, where we can see that when we are reusing the connections, the difference between non-encrypted and encrypted traffic is virtually non-existing.
Yeah.
They are almost the same there.
Right. So this is so on in this test the latency is 50 milliseconds in each direction. So the round trip time is 100 milliseconds.
No, it's 100 milliseconds on each packet, so the round trip time actually becomes
200
200
milliseconds.
milliseconds.
Ah.
Yeah. Moving on to some graphs showing the CPU usage here. And as expected, especially when we are doing full TLS handshake, the CPU time spent goes through the roof for the encrypted connections. The numbers here are in nanoseconds CPU time spent as a total for the Varnish D server over the 10-second runtime of the test. And that is to be expected because of all the complicated math happening as part of this RSA key negotiation. Looking at the reusable connections, it is only around twice the amount of CPU time spent. But none of these graphs are really disturbing, given that Varnish servers have a tendency to just idling anyways and doing nothing on the CPU side of things for most of the part. So these graphs here are interesting to look at, but doesn't really add much to the.
No, I remember like it was 2 or 3 years ago we did a LAN speed test on Varnish on an 80 gigabit network doing HLS, and I think we were able to push 74 gigabits per second through Varnish. Since it was HLS, it was rather big objects. I think there were probably a megabyte or two a piece, so quite big. But in like I think, and they were sort of bleeding edge hardware at the time, so 24 cores on each server, but 22 of them were idle, and the 2 busy cores were, one was occupied by Varnish and the other by the kernel, and 22 were idle. So we probably wouldn't have been able to push those 74 gigabits through SSL, but I mean, we should be able to push quite a significant bit of it through SSL. Would at least CPU usage would not be the thing that would starve us in that situation. So yeah. Okay, so to sort of sum up on the sort of backend latency bits, I mean, on a local area network, the thing that you should keep in mind is establishing a TLS connection is costly. So any sort of reuse of any connection is a good thing. If you're on a like an internet connection, a WAN connection, difference will of course be much smaller, as there is no really you can't. It becomes harder and harder to sort of see the impact that the TLS negotiation will have. And once established, the TLS negotiations, the TLS connections are really fast, and it's hard to sort of discern the performance between a TLS connection and a clear text connection unless you actually measure it. I mean, you probably will have just sitting in front of a browser, you probably won't be able to tell, even though it's measurable. It's a bit about sort of our sort of future features. probably will be expanding the TLS support. So there's something called OCSP stapling, which is would enable Hitch to talk to the certificate authority and to send along a cryptographic ticket to verify that the certificate is still valid. The alternative, of course, is that the client validates the certificate with the certificate authority on its own. And of course, on a busy site, that might end up with quite a bit of traffic towards the CA. Other bits that are currently not implemented is Alpine or NPN. So you could maybe shed some light on what that is.
Yeah, it's a TLS extension where the client can say, I support these protocols. So he can say pretty much I support Speedy and H2 and HTTP1. And then the server can come back with telling you we're talking Speedy or whichever it is, and then it can then point it to a particular endpoint on the backend side supporting this protocol. So that's the functionality we are looking at with NPN or Alpine.
Okay, yeah. So that would be in order to avoid further round trips in order to when negotiating protocols.
Yeah.
Yeah. And of course, I mean, we will, whenever sort of Varnish Cache 4.1 comes out, we'll be wanting to port the current code base to Varnish Cache plus 4.1. So as I mentioned earlier, or as at least as some of you might know, PHK, the architect of Varnish Cache, does not particularly like the idea of linking OpenSSL into Varnish Cache. So far, he will be rejecting any attempt from us to sort of merge this code into Varnish Cache. But yeah, so that's why it's sort of currently the feature is proprietary only. And that's it. That's the whole webinar for today. So thank you, Martin, and thank you, Doug, for helping explaining this. So if you have any questions, feel free to sort of reach out to us on either on email or the Twitter or whatever. It shouldn't be hard to find us. Have a good day. Cheers. Bye.
Bye.